Complex numbers, the intro. So, as you remember, when we were graphing quadratics, to find the real roots, we look at where it crosses the x-axis. Well, not every quadratic crosses the x-axis. As we can see by this basic quadratic, x squared plus 1. So I know you're all envisioning how you're moving to do x squared plus 1. And you go up once, and there are no x-intercepts, because this does not cross the x-axis at all, because we're up 1 unit right here. So this means there are no real roots. If we were to solve this to try to find the roots, we'd have 0 equals x squared plus 1. We'd subtract 1 from both sides. We get x squared equals negative 1. Square root of both sides, we'd get x is equal to plus or minus the square root of negative 1. And here's where the trouble starts. Because that isn't a real number, there's no way that we can multiply two things to get a negative number, or two of the same things, I should say. That brings us to an imaginary number. So it's the square root of a negative number. The square root of negative 1 is called I. So the square root of negative 2 then would be I times the square root of 2. Because the square root of negative 2 is the square root of negative 1 times the square root of 2. We just think about breaking those out that way. And we know that the square root of negative 1 is I, so that's how it all works. So the square root of negative 4 in this next example is 2i. The square root of 4 is 2. The square root of negative 1 is I. And if we have I squared, that would be the square root of negative 1 squared. That gives us negative 1. So I squared is equal to negative 1. That's just a couple of very basic things about imaginary numbers. I think once you get the grasp of it, anytime you see a negative under a radical, that's going to give you an I. And that I comes outside. It's not under the radical. It's not the square root of I. It's just I. So the square root of negative 1 is I. That's what we give, that's the name of that imaginary number. So if you're simplifying square roots, and we don't really need to go through all of this, but this is right from your book. I just wanted to kind of talk you through a couple of the things. You definitely don't have to write down all of these steps. Most of you can probably see it right there, but if you don't, then you can certainly do this. Square root of negative 16 is the square root of 16 times the square root of negative 1. Square root of 16 is 4, so 3 times 4 is 12. And we still have that square root of negative 1, which becomes our I. So 12i is the simplified form of 3 radical negative 16. If we come over to example 1b, we get the opposite of the square root of negative 75. Depending on how you want to do this, you can immediately bring out that I if you want to, or you can deal with the 75. So when you have the square root of 75, you might say, well, 3 goes in there 25 times. That's a perfect square, so let's take that out as a 5. And we get 5 outside. And we still have a 3 inside. So we'll have a 3 inside, and then we still have an I. And typically you will see it written like this, as negative 5 square roots of 3, and then the end of the radical, and then an I. But then that gets a little bit messy and confusing when you're first doing it, so it's nice to kind of bring that I around so there's no confusion about it being under the radical. So negative 5i times the square root of 3. So expressing each number in terms of I. I'm not going to go through all of these examples, but we can certainly take care of one of them. The square root of negative 12, we know it's going to be an I. So if you want to deal with that right off the bat, go ahead. Square root of 12, many of you can now look at that and know that that's 2 radical 3. So that means that the 2 is going to come out because it's 4 times 3. So we get 2i radical 3. And that's it. That's all she wrote. In all of these others, it's the same idea. You simplify whatever you can. When you have that negative under the radical, that becomes your I. That's how to simplify. Solving each equation. Same idea. If you have something squared, so for instance, let's take we'll do example 2C. We want to isolate the variables. We want to get x alone. So subtract 25 from both sides. We get 9x squared is equal to negative 25. So divide both sides by 9. When we divide both sides by 9, we get x squared equals negative 25 ninths. Don't you dare write that as a decimal. Take the square root of both sides. So x is equal to plus or minus the square root of negative 25 over 9. So we get x equals plus or minus. I'm going to jump right to the finish line on this one. That is 5i divided by 3, or 5/3 I, however you want to think of that. If you need to, talk to someone about how that all happened, if that was too quick for you. A complex number is really just a number that has a real part and an imaginary part. So it's written in the form of a plus bi. A is the real part, and the bi is the imaginary part of it, because I is the square root of negative 1. So real numbers fall into that, and so do pure imaginary numbers. A pure imaginary number would be something like 3i. That's a pure imaginary number because there's no real part to it, just the imaginary part. But when you see it as a plus bi, that's a complex number. So there's a real part and an imaginary part. A is the real number part, like 7, and then plus 3i. We can't combine those. We can't do 7 plus 3 because that 3 has the I with it. So that has to stay like that. So 7 plus 3i would be the simplified form of this one. Complex conjugates. You're going to like this because we've really already done this. So let's, for a minute, just pretend we don't have any of this stuff. We can pretend you don't see that. The complex conjugate, we have 2i minus 15. You want to write it in the a plus bi form, which just means changing the order. So we have the negative 15, because that's what it was. And then we have the 2i, because that's what it was. And we just change the order a little bit. And then once you write it that way, you change the sign that's with the imaginary part. The reason it's a complex conjugate, we have negative 15 plus 2i. If we now multiply this by negative 15 minus 2i, good things are going to happen. Namely, those I terms are going to drop out. So when we multiply this, negative 15 times negative 15 is 225. Negative 30i plus 30i and minus 4i squared. Now, 30i and negative 30i are gone. So now we have 225 minus 4. Remember we said I squared is equal to negative 1. So this is 225 plus 4, which is 229. So when we multiply those together, that's the complex conjugate, because when we multiply them out, we no longer have that imaginary part. And that's how it works out with complex conjugates. So you didn't need to do that for this problem. You just needed to come up with the complex conjugate. I just wanted to give you some idea of what that means and what it does. Very similar to what we've been doing with radicals. We want that radical to disappear. Here we want that I to disappear. And any complex number has a complex conjugate, which when you multiply them together, you get a real number. So that's all the fun and games for today. So hope this went well for you. Good luck with it.